Hi, my name is Cameron, and together with me I have Lucas and Joshua, and together we are team brothers. And this is our submission. For our submission, we've built an AI/ML pipeline for filtering Google location reviews. I'll walk you through the actual code, organized across 5 notebooks, namely feature engineering, labeling, training, active learning, and evaluation. Each one is modular, so the pipeline can be repeated or scaled. Starting with feature engineering, we generate structured features from reviews, users, and images, which captures counts, text metrics, and behavioral signals. We then move towards labeling, where we use multiple LLMs to assign truth labels to ensure consistency across our agreement checks. Next, we move to model training, where we train our model on engineered feedback and optimize with validation feedback. We move on to active learning, where the model predicts labels based on new data, and where we do class-aware sampling, which ensures balanced categories, which is reinserted into labeling for us to repeat this pipeline multiple times. And lastly, we do model evaluation, where we test against held-out data, where we measure accuracy, precision, recall, and reliability metrics. Let me walk you through the exact code right now. Here is feature engineering, and you can see the exact models or the exact features that we have engineered. We range from things like sentiment analysis to time-based features, topic modeling, keyword extraction, policy insights, stylistic features, emotional and expressive markers, as well as user information and photo information. After these features are done, we move on to labeling. For labeling, we are using multiple open source LLMs to assign the true value to each set of data. As you can see here, we are using Mistral, Gemma, and Llama for this. At the end of the prompts, we should have a label dataset over here. After that, we do some encoding and data preparation, such as standardization and normalization, to prepare and data splitting as well, to prepare our data to train the model. After that, we feed this into model training. After this, we go to the model training notebook. In the model training notebook, we have 3 branches, which is namely the text branch, the categorical branch, and the continuous branch. You can see that over here. In forward, the 3 branches are concatenated and pass through a classifier layer to predict the class logics. After that, the training loop is handled by this method over here, which is train_enhanced_model over here. This computes the class weights, tokenizes the text with auto tokenizer, and trains with the Hugging Face trainer using early stopping. These artifacts saved are the train weights and the tokenizer over here. And at the end, you can see our final output over here. After that, we head to the active learning notebook. Here, we score our unlabeled reviews using the trained model. The method known as calculate_uncertainty computes entropy-based uncertainty, and then class_where sampling ensures balanced sampling, where it chooses the most uncertain samples per class to avoid imbalanced training. Let me head there over now. Yep, here. And you can see at the end, we return the user IDs of these text IDs, which we are going to refeed into the cycle over here. Last but not least, we have our model evaluation. Here we compute per class precision, recall, and F1 with our per class metrics. You can see what's happening over here. And to calculate to calibrate our probabilities, we have a method called _save PRBOA to confidence, which converts our raw softmax scores into confidence levels. This notebook also includes error analysis and even a cost of false positive table to show business impact. So in summary, we have 5 main notebooks, and this is what each of them do. You can find our information in the GitHub repository, and we'll be happy to take any questions. Thank you.